the sky's the limit. You look at all various different processes that are run in businesses, from supply chain management to support, the software development life cycle. We talked about HR. There might be consumer-related processes. Banking and finance has a ton of processes within them. These can all become agentic and connect into this agentic fabric, agentic web that constitutes the agentic fabric of a business. Yeah, when we talk about human on the loop, we're kind of implying some level of autonomy for the AI system to decide when to surface a situation to a human. So we're kind of basically saying, okay, we will allow the AI system some level of autonomy. So it's semi-autonomous. Sometimes it makes the decisions on its own when we're comfortable and we trust it to do so. And sometimes, if it's not very confident in its own choices, or based on some rules or regulations, it's not supposed to make a decision in that particular situation, it surfaces it to a human. So we call that human on the loop. In the other scenario, more familiar scenario, we have human in the loop, which means every single decision that the AI system is going to make in affecting the world has to be rubber stamped basically by a human. And we've been here before where new technologies have come along. They've automated certain things that we've been doing manually, and jobs have shifted and changed in their nature. The biggest concern here, though, is the rate of that disruption and change. So there's two topics here: whether we will all be jobless sitting on the beach, which I don't subscribe to. I don't think that's going to happen. I think we'll all be actually much busier in the longer run. But then there's the more concerning transition period, where many of the tasks that we do can be automated, and we can use AI systems for those tasks. So there's a disruptive transition period. And the speed at which we can basically withstand this change and kind of adapt to it is the concerning part.
Welcome to the AI Adoption Podcast. I'm your host, Professor Ashley Braganza, and it delights me to welcome Babak Hodjat from Cognizant to this episode. Babak, before we go much further, could I ask you to introduce yourself and your role in Cognizant, and say a little bit about Cognizant as well, please?
Sure. I'm the Chief AI Officer for Cognizant, where I help with AI strategy, and I run innovation. I run our AI labs here in San Francisco as well as in Bangalore. And we do core AI research and bring a lot of that innovation to our clients through various different platforms.
Great. Thank you so much. I'd really like to start our conversation by asking you to reflect on, the hype versus the reality of AI. The more I read, particularly in the more popular press, and I'm not talking about the more scientific press and journal articles, but in the popular press, it's like AI is going to solve just about every problem that we have. Go on, give us a dose of the hype versus the reality, Babak.
Yes, unfortunately, in the world of AI, expectation has always exceeded, not just the reality and even the potential. And there is a lot of hype. AI is not only compared to the most intelligent human, but our collective intelligence, and perhaps even further than that to magic and God. Um, but there is substance. There is a lot of power, a lot of potential. For the first time, we've been able to have a machine abstract the world similarly to how humans abstract the world, and that has allowed these models, these systems, to understand and produce natural language on par with us, and not just one natural language, pretty much multiple languages at the same time, and to be able to reason and maintain reliably a chain of reasoning without breaking that chain of reasoning. These are substantial. I've been in AI since the late 80s, and these were problems that we thought were, never going to be solved, or we would be inching our ways towards them. And a surprising approach, starting from very simple first principles, has brought this kind of capability, this generally intelligent capability out there. So the potential is very large. There are limitations. It's not talked about that much. The adoption itself has been impressive, it has been rather in areas that are pretty standard. So I think we're even scratching the surface on adoption and places where AI can be used. Having said all of this and all this potential and excitement, the expectation still exceeds where we are.
Well, what would you say are some of the major limitations then of the technology of AI technologies at the moment?
In simple terms, the state of the art in AI today does not learn from lived experience, which means that um, unlike us humans, we kind of learn from the environment, from our experience, from our context through time. We adjust our abstractions. One counterexample can make us change our mind. AI systems today cannot do that. They are trained offline, and then they're pretty much fixed. And in the analogy would be the movie Memento. For those of you who haven't seen it, is this guy that has like short-term memory issues, falls asleep, wakes up, and has forgotten everything, and has to kind of read up everything on tattoos and so forth, just to remember who he is and what happened. Um, it's very akin to that. So large language models, which is the AI behind this whole AI revolution today, are very similar to that. You talk to a large language model, and it seems very intelligent and can answer questions to you, and it'll remember the dialogue and so forth. But you go away, turn it off, or wipe its context and come back to it, and it will not remember a single point that you made. And that's, through cheaty ways, we can kind of try to remind it every time, kind of like the movie Memento. And that takes us so far. But there's some other fundamental limitations that this brings, which is the fact that it can't change its mind. It can't change its abstractions with new encounters. So that, to me, that is one of the biggest limitations of AI today. There are other limitations as well. So we should think of the state of the art in AI as being a different kind of intelligence. Similar, some overlaps to how we think and how humans operate, but different.
Do you think AI agents or agentic AI will address some of those limitations?
Some limitations can be addressed through modularization. So agentic AI, and especially multi-agent systems, give us this ability to engineer these systems, kind of restrict them, give them a domain of expertise, domain of focus, and say, here's what you do, here's some data that you can work with, and here are other agents that you might be working with. And that gives us as humans some level of design sort of input into how we build these systems, what set of tools we give them, and how we allow them to operate in the world. An agent is basically a large language model plus some code that actuates on the intent of that large language model. So it allows the AI to actually affect the world, so do things, look at its environment and do things. Um, uh, Things like making systems more trustworthy, more reliable, will require this kind of modularization. So agent-based systems can address that. Um, but it still doesn't solve the fundamental problem that I just mentioned, which is um, these systems still need to be reminded of the context they are, the history in which they've operated. They need to be constantly reminded as to how to think and how to reason, and that does not go away. A human working in a job learns and experiences in that job, and as its context changes, can adjust to that and change its way of thinking about the job. And a large language model cannot do that. So, as humans, we have to constantly remind or modify um, and sort of help nudge these systems. And I think agentic systems will always be in this constant state of re-engineering to make them work.
That's interesting. In terms of some use cases, I wondered if you could, based on your experience, maybe share some use cases of where you've seen these AI systems work well.
Yeah, let me give you a use case that we implemented in-house within Cognizant. We are a very large company, more than 300,000 associates work at Cognizant around the world. And we all, as Cognizant employees, use our intranet. And the intranet is a collection of apps through a web interface that allow us to do our HR, our finance, legal related, have queries, have to fill out a form to take some time off. That's what we use.
Mhm.
It's a single point of entry, but it's these are disparate apps. Some of them built in-house, some of them provisioned from third party, and it's sort of this mishmash collection. Most large companies have something similar. So what we did is we decided to apply AI to this system. And by building these AI agents that represent the various different applications and within a hierarchy that makes sense. For example, we have a top agent. If you don't simply know what app would be appropriate for whatever you want to do, you talk to that top agent, and the top agent then talks within this hierarchy. It has an HR agent and legal, finance, sales, and so forth. And each one of those agents in turn have what we call down chain agents that might be sitting on these various different apps. So HR might actually be sitting on your time off app as well as we do timesheets. So for example, billing to various different clients, that might be another thing. Payroll, insurance, whatever, right? Um, so we started building this nucleus of a multi-agentic system with agents sitting on these apps and operating them on behalf of the user. And the way we connected these agents was so that the human user can express an intent, and the agents would then work together. They would be talking to each other and trying to figure out which agents within this, what we call agent network, would have a role to play and consolidating that into, this spontaneously forming team of agents that can come together and, resolve or address whatever intent the user has. So we built this, and we also came up with the process for anyone within Cognizant to be able to create their own agents and be able to go through a set of steps to validate and test and maybe sandbox their agentic systems. Maybe these agents are coming from third parties, and then plug them in to the larger agentic system. So it starts expanding as new functionality, new apps, new agents are becoming available. So we built this, within the process. For example, our sales team decided to bring Agentforce from Salesforce.com. Our IT team had ServiceNow, and that agent was plugged in. So I'm just giving you a description as well as the steps that we took to actually build this. And once we built it and rolled it out, it became very clear very quickly that it is very, very effective, not just in addressing any query or command that you might have, but also in breaking the organizational silos. Oftentimes, something that you want to do might hit multiple different applications or an order by which you need to do things. An example I use a lot is, a life change event. Here in the US, if your son or daughter turns 26, they can't be on your insurance anymore. And so maybe that's the query. So you just express the reality of a life change event. And these agents spontaneously come together and say, well, there's an insurance change. I'm going to make that, but I need some information about your child, but I can get that from the HR system. And oh, by the way, we might actually have to make some changes to your deductibles on your payroll because of this shift and so forth. So now you have multiple different systems coming together and just getting stuff done for you. So it's all more efficient, more productive. And we looked at a 3-month window of this system having been deployed. And it turns out that we reduced significantly the number of tickets that people would be opening up for support on various different elements as soon as we turn this system on. It's very, very popular. It's handled more than 11 million such commands so far. And the ROI is just built in. So just giving you one example of that, but the sky's the limit. You look at all various different processes that are run in businesses, from supply chain management to support, the software development lifecycle. We talked about HR. There might be consumer-related processes. Banking and finance has a ton of processes within them. These can all become agentic and connect into this agentic fabric, agentic web that constitutes the agentic fabric of a business.
Babak, thank you so much for explaining how AI is being used internally and how AI agents are being deployed internally. I wondered if you could maybe give us an example of what is possible in some of those other areas that you talked about, whether it's financial services or supply chains.
Yeah. So let's take financial services, for example. Oftentimes, if we're talking about a banking kind of setup, you have multiple different banking products. What you want to do is, depending on the client, you want to decide what banking product to pitch at what time, what point, and how. For example, so there's a decision to be made. There's some awareness of who that client is that you want to pitch at, and how best to reach out to them and when and so forth. So these are all choices and reasoning that you want your AI system to make. You want to pull from information that you have about the client, information that you have about the products that you can probably configure for the client. And every single one of those could be an AI agent, each looking at its own data and its context, and then consolidating and talking to each other depending on what the context of the client is, and making a choice and decisions. So that's just one example of how a system like that could work. We have many, many design patterns. I've talked about this design pattern where you have agents autonomously running, for example, in network nodes for a telco, where the agent's actually running on the network node, monitoring traffic, and maybe autonomously making some decisions on the traffic or some errors or issues that might happen there. But at the same time, be connected to a web of agents that allow supervisors and users command and control, as well as reporting over what's happening within the network. And so that's more geographically based, but it's also sort of a combination of autonomously running agents and what we call human on the loop. So that's actually an interesting design pattern, because we often think about humans as rubber stamping every decision that an AI system makes. That's not always practical, especially if the frequency of decision making is rather high. So what we want is these AI agents themselves to be able to make a choice and decide whether they're confident enough in a choice or a decision or not. And if not, or if the rules and regulations tell them that a certain context has to be surfaced to a user, to actually surface them and have the user take a look.
Thank you. Could I just go back half a second and just ask you to explain? You used the phrase humans on the loop. Could you just explain that for those who may not understand what that phrase means, please?
Yeah, when we talk about human on the loop, we're kind of implying some level of autonomy for the AI system to decide when to surface a situation to a human. So we're kind of basically saying, okay, we will allow the AI system some level of autonomy. So it's semi-autonomous. Sometimes it makes the decisions on its own when we're comfortable and we trust it to do so. And sometimes, if it's not very confident in its own choices, or based on some rules or regulations, it's not supposed to make a decision in that particular situation, it surfaces it to a human. So we call that human on the loop. In, in the other scenario, more familiar scenario, you have human in the loop, which means every single decision that the AI system is going to make in affecting the world has to be rubber stamped basically by a human. That's just really, in many cases, not practical.
Babak, thank you for explaining some of that jargon, which I think for those in the AI world, we kind of understand humans on the loop and in the loop. But for listeners who are coming to this for the first time, thank you for that explanation. Um, but moving the conversation on a little bit, one of the concerns that I've heard expressed is that as AI is being rolled out and becoming much more part of, and you used this phrase earlier, and I really liked it, more into the fabric of society, the fabric of our lives, people are starting to see that the power that AI gives organizations is being kind of consolidated or being brought into a smaller and smaller number of hands. And this concentration of power is of concern. I just wondered, from your perspective, what are your thoughts on that, please?
Yeah, that is a concern. Hopefully, a short-term concern that will start going away. But that is a concern. The reason for that is because building these models takes a lot of processing capacity and a lot of data. So just training the models takes a lot of basically capital. And only a few companies in the world can do that right now. And so that means that they have control over these commercial models that happen to be the state of the art. There are open source models, there are models being developed, smaller models being developed in academia. In the open source world, I think the models from a capability perspective are maybe 6 to 9 months behind right now, which is a gap that's closing, which gives us some hope that these systems will hopefully in the future not remain in the exclusive domain of these commercial systems. At least from the widespread usage perspective, we should be able to use lesser yet still capable models that are open source and available to everyone. That is the hope. And we talked about modularization and multi-agent systems. There is a threshold beyond which, if your large language model is more powerful, it doesn't really help you that much, and there's a cost associated to it as well. So there's some hope that this gap closing and the applicability and us learning how to modularize these systems and multi-agent systems is going to take away that advantage right now that a few companies have. The reason why these companies have this advantage and continue to invest is because there is what we call scaling laws in building these large language models. It seems like the larger the model and the more processing capacity we throw at it to train it, and the more data we throw at it to train it, the more capable they become. And so there's this race in amongst a few large commercial companies to kind of one up each other and try to build a larger, better, more capable system. But as I mentioned, I think for the vast majority of use cases out there, there's a threshold beyond which having a system that abstracts better and reasons better might not give us the same cost benefit as using a lesser model in a modularized multi-agent way.
Thank you for that, Babak. Another concern that I think people have in terms of these AI technologies is the impact on jobs and the disruption that's going to be created in organizations. Again, from the work that you're doing, what's your impression on that?
It's a real concern. And we've been here before where new technologies have come along. They've automated certain things that we've been doing manually. And jobs have shifted and changed in their nature. The biggest concern here, though, is the rate of that disruption and change. So there's two topics here. Whether, we will all be jobless sitting on the beach, which I don't subscribe to. I don't think that's going to happen. I think we'll all be actually much busier in the longer run. But then there's the more concerning transition period where many of the tasks that we do can be automated, and we can use AI systems for those tasks. So there's a disruptive transition period. Um, and the speed at which we can uh, basically withstand this change and kind of adapt to it is the concerning part because the rate of change is so fast. Something like automobiles coming along and displacing the horse and cart, it took decades. And so, we had time, like society had time to adjust to that. However, something like reasoning systems using AI coming along and being able to automate many, many tasks within our jobs and some jobs entirely, that's unfolding within not even years. It's unfolding within months, and that's concerning. And so we as a society we have to be aware of that and take steps to mitigate.
And I guess that kind of naturally leads me to trying to find out what are the areas of research that Cognizant and you and your team are involved with at the moment in terms of looking forward.
Yeah, so one of the things we do is, is we look at the limitations of AI systems today and how we can build AI systems that are reliable and trustworthy. And so there are a number of tracks within Cognizant on that where we do research and we've had breakthroughs that have gone viral. Um, a very important track there has to do with reliability. So if you take the state of the art in AI and have it start reasoning in order to solve a problem, it does pretty well. I mean, it's very impressive. It can go on for hundreds of reasoning steps without errors and solve some, pretty sophisticated problems. But there seems to be this catastrophic breakdown in the reasoning chain that happens at around 300, 400 steps of reasoning, that a single large language model kind of fails. And that might, again, that sounds impressive and it is, but if we're relying on these agentic AI systems to reason in the wild for, running and helping us make our businesses more productive, 300, 400 reasoning steps is nothing. Um, and those catastrophic breakdowns can be costly. So what we've done is we kind of learned from telecommunications. We've been here before. In the past, a truck running down the road would flip a bit in your computer through the noise. And so we've had to build resilience and error correction into our telecommunication systems. And so the analogy to that is what we came up with, where we have agents checking the reasoning steps of other agents and voting on them. And through that voting mechanism, deciding which reasoning step to take. And doing that in a certain configuration can reduce error significantly to the point where we can chain together in our paper that came out in December, we can chain together 1 million reasoning steps with 0 errors. And that's very, very significant because it kind of makes the difference between being able to trust these systems to operate reliably and, it's something that maybe solves a problem in the lab and in a one-time basis.
Thank you for sharing that. I'm going to ask you as well now to make some predictions. Where are we going to be in, say, 2027, 2028? Where are we going to be with these technologies? Are we going to have achieved artificial general intelligence by then? Where's that on this roadmap looking forward? So predictions and kind of where are we with AGI?
Yeah, I mean, I'm not a futurist, so take it for what it is. I think just looking at where we are right now, the natural progression of that in 2027 is going to be wider adoption of agentic systems and connecting these agentic systems with one another, and also figuring out how we connect agents that are representing different entities. So you might have a business with some agents and some of those agents talking to another business with their own agents. So there might be some overlap and alignment, but not complete alignment between them. Or maybe agents representing consumers talking to agents representing businesses like B2Cs. That has not quite been resolved yet. We don't quite have the sort of the trust framework around how that could happen, but that is more a matter of protocol and standards that we have to figure out in order to be able to unleash, create this worldwide agentic web. So that will be something that I think I can safely predict in the next few months and years will happen. And of course, breakthroughs in reliability and applying AI in many, many more places beyond the standard, like, software development process or let's say support line and so forth. So that's one. When it comes to AGI, AGI is difficult to pin down as far as the definition is concerned. By some sort of perspectives, we might have actually already achieved AGI. These large language models are generally intelligent. They can speak multiple languages and they can reason in situations they've never encountered before. And they abstract the world similarly to humans. So, I mean, that could be considered AGI. If what we mean by AGI is, and they're smarter, just try them out. I mean, they know much more than any single one of us. But if by AGI what we mean is, showing all of the various different facets of intelligence that as a human we show, such as learning on the job, learning through lived experience, for example, and continue to abstract, and even some manners of creativity. These large language models are creative, but creative to a certain limit. We are not there. I think some of these facets might emerge as we grow these models ever larger and throw more data at them. But some of them will require complete rethinking of the fundamentals of how we've done AI. And so, who's to say that kind of a breakthrough is going to come again in the next couple of years, or it might be decades before we actually have that.
Babak, thank you for sharing your predictions, and I appreciate you taking up that challenge as I put you on the spot to gaze into a crystal ball and give us your views. I'd also really like to thank you for joining me on the AI Adoption podcast, Babak, for sharing so openly the work that's going on internally within Cognizant, and also some use cases from the work that you're doing with organizations and industries elsewhere. I think for me, what's really stand out is the dose of reality that you have brought to this whole conversation about AI, in terms of not just what it has in terms of potential and what it can do, but also in terms of, some of its limitations and some of the things that it can't do, and it, there is still so much work to be done to fully realize the benefits of AI. So thank you for joining me today. Thank you to my listeners as well for taking the time and staying with us for the podcast series, but also for this episode. So Babak, thank you so much.
My pleasure. Thank you so much for having me.